Hey there, it's Joseph from RoboFlow. Today I'm going to show you how you can train your very own YOLO v4 Tiny object detection model on any dataset of your choice using the Darknet framework. Okay, so I'm going to be using my model to teach it what objects look like in infrared thermal images. That means images that were captured using a thermal camera to read the surface temperatures of objects around me. I actually have this dataset here on my desktop, and you can see an example image here. This is actually some that's just on a footpath. There's some images here of like candles. There's an image here of a backyard. Here's an image of my dog, etc., etc. Now, I'll show you where to find this dataset here in a second, but before that, let me show you some real outputs of the model that we're about to train. So let me go on over to my notebook here. This is when we're all said and done. The model identifies, look, it found my dog here, it found my dog here, and it found a dog in my backyard, and it found a dog in this photo, and it found a person and a dog in this photo, etc., etc. So this model does a really good job at identifying the objects, even as thermal objects, from my images. Now, before I get too far, I want to explain to you what YOLO v4 Tiny is and why you might want to use it on given datasets. Then I'll show you where you can find the thermal infrared images that I have that we're going to use for today's discussion. Next, we'll get our data ready. We'll prepare it, check our annotations, make sure everything looks just right before we go about training. Then we'll train a model using Google Colab and free resources in the Darknet framework. Finally, we'll show some inference, like I just spoiled here at the end. Okay, so let me talk to you a little bit more about what YOLO v4 is. Let me minimize myself and just, there we go. And I'm gonna go into present mode and voila. Okay, so training YOLO v4 on a custom data set. Now, you're naturally wondering, what is YOLO v4? Okay, YOLO v4 builds on the progress of YOLO v4, and YOLO v4 Tiny is built to emphasize model speed and small model size for faster inference times, even in small constrained compute environments. So what exactly does that mean? Well, it came out in June 24, 2020 by Alexei Petrovsky, who released the YOLO v4 larger full model. It achieves 40.2% MAP, mean average precision, on the COCO benchmark versus 64.9 on YOLO v4. So yeah, it's significantly less accurate, but it achieves 371 frames per second using a GTX 1080 Ti compared to less than 50 on the full YOLO v4 model. Wow, so this thing is fast. So that might ask you, why would you use YOLO v4 Tiny? It's all about speed. Anyone aiming to use a fast model that might need to work in a constrained compute environment but wants fast results should consider trying YOLO v4 Tiny. What do I mean by constrained compute environment? I mean things like a mobile application on a phone where you don't have the same benefits of full GPUs that you have on a server or a computer. Maybe even a CPU. In the paper, Alexei Petrovsky shows that even on a CPU, you can achieve 40-ish frames per second with an i7 processor. In fact, on a Jetson Nano, Petrovsky was able to achieve 29 frames per second. So that means any embedded inference device is also a great place to consider using YOLO v4 Tiny. Lastly, anyone presently using YOLO v3 Tiny, it's time to upgrade. Let me show you a side-by-side of YOLO v3 Tiny versus YOLO v4 that Alexei published. So here's an example of YOLO v3 Tiny on a busy street. And it does a pretty good job of finding cars, people, persons, etc. But let me show you side-by-side what does YOLO v4 Tiny do on this same data set. This. Look at those differences. Much better. Now, let's look at the stats themselves. So YOLO v4 you can see is actually up here at 64.9 MAP at 50 and approximately under 50 frames per second, just as I said to you. Now way over here you see YOLO v4 Tiny. Yes, it's a lot less accurate, but look how fast it is in comparison. So YOLO v4 Tiny is a great model if you need to maybe identify a single object, you're working on a mobile device, embedded compute, all that stuff. Now, a small word of caution before we get too far. YOLO v4 Tiny is natively written in the Darknet framework, and today's discussion we're going to use the Darknet framework to train it, which is a little tougher to use than TensorFlow or PyTorch. Stay tuned for additional models that we use in those frameworks, however. Nonetheless, we'll still get a model fully trained, as we always do here at RoboFlow. Okay, now that's all good and well. Now, what's the dataset we're going to use? Okay, well, the dataset is actually available on public.roboflow.ai. If you scroll down or scroll up, you have the thermal, dogs, and people dataset collected by, I know that guy. And it's shared in a public domain, which means you can use it for any of your projects. So this dataset here, look, is an example image of a man and his dog, nice there, standing tall and square. Now, you can go ahead and get this resized 416 by 416 if you wanted to download it directly of all these thermal people and dogs. Just hit that download button up there. If you want the source dataset itself, what I encourage you to do is click fork up here. Click fork. And if you click fork, this allows you to copy the dataset directly to your RoboFlow account. So I'm going to go ahead and do that. I'm going to click fork dataset, and this is going to copy it to my empty RoboFlow account. And boom, quick little refresh, and there you go. Look, dataset was added to my account, just like that. So now with the dataset, I have the ability to look at the raw dataset health check. And so I see that I have 203 images, 257 annotations, so a few objects in each of my images. The average image size is a nice 69 megapixels, and actually all the images are the same size from 69 to 69. That's because all the images are the same size, 960 by 720 median image ratio. My dataset's relatively balanced of person and dog, and everything's the same size, or actually a couple of my images are not the same size, I should mention. Some of them are actually rotated a couple of different ways. Some of them are wider than they are tall, and some of them are taller than they are wide. I look at my annotation heat map here, and I see the dogs and the people are generally in the center of my images, maybe as I would expect. Okay, and so with this data set, I have all my images, and everything looks pretty good. Someone on a footpath, a dog over here. His name is Bear, by the way. Say hello to Bear. Say hello to Bear in the comments. And person and dog, etc., etc. So now I have my data. My annotations all look pretty good. If you have your own data set, I'll show you how to do that too. If you had your own data set, you would go up here and click Create Dataset. You would give it a name. So I'm going to call mine Thermal Dogs again. It is an object detection data set. That is, we have bounding boxes. And I would give it a name. And I'm going to call mine Dogs, or my annotation group, which is like, what's everything in this? So I'm going to say Dogs Person. And okay, now if I had my images and they were locally, just as I had on my computer here, I have all of my images and my annotations. Now my annotations for this data set happen to be in VOC XML format, but I need them to be in YOLO Darknet. RoboFlow handles that conversion for me. In fact, you can upload annotations from any format. Coco JSON, TensorFlow CSV, Supervisely, Label Box, anything. You can upload it to RoboFlow. We'll recognize it as long as it's one of the 34 standard supported formats, and we'll parse it for you. So here, I would actually just go ahead and drop my images in, get my data into RoboFlow like this, and it processes all of my images and all of my annotations, and it checks and looks for anything that's not annotated, everything that is annotated, and everything looks good. I would start my upload, and I could modify my train valid test splits, and RoboFlow does that for me too. And once I know that my splits look good, I'm going to go with the standard 70-20-10. Then they all just upload, and they're private to my own RoboFlow account. And so I'm going to go back to my account while this gives, another 20 seconds or so. And if I go back to my data sets here, you actually see I have the thermal dogs and people data set that I forked from the public data sets, right? But then I also have the same data set again, just for the sake of example, that I've uploaded here. And you can actually see it updating live as all of those images finish processing. And boom, once they finish processing, just as I would expect, I have all that data there as well. Okay, great. So now that I have this data, I'm going to go to my original one, the one that I forked. I need to have my data, and I want to do things like resize everything to be correctly formatted for my model. I want to increase augmentation so I have more images for my model to learn from. These are all the sorts of steps that you need to prepare for your data to be ready to be modeled. So I'm going to add a preprocessing step. I'm going to resize my images, and I'm going to stretch them to all be 416 by 416. I could modify those, say to 640 by 640 if I like. Whatever works, but know that for YOLO's, the YOLO family of models, your dimensions should be multiples of 32 for the way that it performs its convolutions. So I'm going to save and apply that step. And, maybe I want to try some of these other steps. Like maybe I want to try breaking my image into 2x2s or something like this. Whatever makes sense based on the context of your problem. I'm just going to resize for this first run. And then I'm going to also add some augmentation steps, which increase my dataset size and variation so that my model can learn from a wider array of examples. So here I'm going to do some flips, like horizontal flips. Vertical flips don't make a ton of sense for my dataset because I'm going to say my camera is always right side up. So I'm going to apply a horizontal flip. I'm also going to add maybe a little bit of random cropping, random zooming in on different parts of the image. 0 to 30% looks pretty good. And maybe a little bit of brightness changes, maybe a little bit more exposure or less exposure on those given pixels. And those all look pretty good. So now I'm going to generate a version, but not so fast. Notice that not only am I increasing this variation to my images, but before I generate my version, I actually can select and increase my dataset size. Here by default, we're going to increase from 203 images, and we're going to add 3 versions per image, which might get me up to 609. It won't get me exactly there because RoboFlow does random augmentation and we dedupe images. So if the same image were produced twice, when it were generated, we drop it, so there's only one. But generally, it's going to increase your dataset size for free. And all of the annotations are updated correctly. So when I flip that image, all of the annotations are updated to the new object's position. Wow. So I'm going to go ahead and generate my data set. So I'm going to call this V1. And maybe I'm going to call it V1 flip, bright, crop. Flip, bright, crop. So when I go here and I click generate, then RoboFlow goes ahead and it fires off all of that job. So each of my images undergo those random variations, randomly brighter, randomly cropped, randomly flipped, and boom. So I randomly got 487 images here for my source data set, which dramatically increases the size of my training set. Now with all these images and everything that looks pretty good, I'm going to go ahead here and I want to export my data to the format that I need for training. Okay, so what have we done so far? We've got our data set, the annotations look good, we looked at the specs of the data set, we got everything resized, we generated new training data. Now it's time for training. Training. So the training that we're going to do is we're going to go to the models.roboflow.ai to find the RoboFlow model library. And here we have a ton of different models that we can try. Now this video, we're doing YOLO v4 Tiny and the Darknet framework. So Darknet, object detection, YOLO v4 Tiny. And I'm going to click here and I'm going to open up the Google Colab notebook. The Google Colab notebook, which gives me the ability, to have my own GPU resources included in this given notebook. So now, before I can use this, critical step, I need to go up here and click File, Save a Copy to Drive. Because right now I'm looking at the RoboFlow version, but I need my own version. So I'm going to save a copy to Drive, which gives me my own Collab notebook. Now I'm going to X out of the original, and with copy, I'm just going to call it JN Thermal YOLO v4 Tiny Darknet RoboFlow. Great. So now I have my own notebook version of a YOLO v4 model in a Collab notebook. I have my data in RoboFlow over here. So I need to export my data from RoboFlow if I want to use this Collab notebook. And the format that I need to export it in matters a lot. So which format are we going to use? Coco JSON, Pascal VARC? We're using YOLO Darknet, remember? So we need the YOLO Darknet format. And I'm going to click Show Download Code here. And actually, this is going to create a download code that I don't want to share with you guys because you don't want to share your key with anyone. So while that zips, I'm going to navigate away. I'm actually going to bring that on a screen that you can't see. And now I have a given code snippet, a little code snippet that I copy that code snippet. Copy that code snippet. Now what does that code snippet look like? I can actually show you over here if you're really so curious. The code snippet, the secret code snippet looks like this. Oops, I downloaded it locally. I want to show download code. Show download code. The code snippet looks like this. My keys are blacked out. You can't see them. Copy that, and then you're going to go back into the notebook. And here's where things get ready. So first things first, we need to make sure we have the right CUDA version to be able to use our GPU effectively and set everything up correctly. The next thing that we're going to do is we're going to connect our Colab notebook to our Google Drive. Now, this is Google asking Google to have access to your stuff. So I'm going to click that, and then, yeah, it's like, hey, can Google have access to Google's own products? This is what happens at big companies. So I'm going to click Allow, and then I'm going to copy that key, and then I'm going to paste that key right into here, paste it, and now my Google Colab notebook can talk to my Google Drive, and that looks great. Now, I can actually run this cell, but Google Colab now comes with the right version of cuDNN, so this doesn't actually matter anymore, even if this isn't in my notebook. But just run the cell for posterity, for old time's sake. Now, I'm going to check and see the OpenCV version I have. Okay, that looks good. I'm going to check which version of GPU that I have, and here I have a NVIDIA SMI. I have a Tesla K80 on the Colab free tier. That's kind of what you get. Now I can double check the cuDNN install, make sure everything looks right, and indeed it does. Now I'm ready to install Darknet. So I'm going to CD on into content, and I'm going to remove anything that's already there. Then I'm going to clone the Darknet repository from RoboFlow. See here, from RoboFlow, Darknet. I'm grabbing it. It's now in there. I'm going to CD into the Darknet directory, which you can see was created over there. And I'm going to run that make file, which creates and gets ready all the C code and source that I need ready for getting to use the Darknet framework. Next, I'm going to be able to grab the specific weights that I get. So this wget link is grabbing the links from Alexi's GitHub, which includes the YOLO v4 tiny weights and the YOLO v4 convolutional weights as I need them. And those are just going to run along their merry way. Okay, so everything's set up in our notebook, but we don't have our data yet. So we need to copy our link from RoboFlow and paste it here. Now, I'm going to paste it here, but I'm going to move this out of camera frame. Move that out of camera frame. And this is where you're pasting in the link that we got from RoboFlow. This link, copy, and paste it here, okay? So I'm going to move that out of frame so you can't see. I'm going to run that. I'm going to remove my link after I run that. Removed. And then move that back into frame so you can see it. Okay, so I pasted in my link here, and then I removed it. So all of my images are now in this directory. I can refresh over here, and inside Darknet, that's where we cloned everything, or where we downloaded everything. Inside the Darknet directory, I have all of my data in train, in test, and in valid. Okay? So that's great. My data's there. Now I'm going to set up the Darknet directories. So I'm going to copy all the relevant files and make sure that they're pasted into the correct positions, which also writes the file names to be ready to say where the train, test, valid directories are. I'm going to write my custom training configuration, and this is where we say the max batches, which typically we do the number of classes times 2,000. So 2,000 iterations per class is pretty common for what we do for training. Okay, so I'm going to write that config file, and this is the config file for YOLO v4 tiny. So YOLO v4 big is, I think, 167 layers. YOLO v4 tiny is less than 40. That's why it's so small, and it's able to be run on multiple different environments. Okay, so that's all written, and that looks good. Now I can cat, which means print out all of the configuration file for my YOLO v4 tiny, and this is the configuration file I was just telling you about. The specifying those few number of layers in comparison to YOLO v4. Then I'm going to go ahead and kick off training. Kick off training. Doo, doo, doo. Train, train, train. Choo, choo. So at this point is all the model gets compiled. Each of these layers, you can see all of the layers. Layer 0 up through 37 here. And once all that stuff gets ready and trained, then I'm going to actually jump over to my other notebook where I've already run all of this stuff because of movie magic. And so at this point, where I've already run everything in my given notebook, I can actually runtime restart and run before. Restart runtime, yes. Run before, yes. Okay, so here I just wanted to show you in this notebook, this is how long it takes to train each iteration on YOLO v4 Tiny. Now, this notebook is actually using a P100 instead of a K80, but you can see it's flying through each of these iterations. Each one is taking just fractions, 0.000003 or 4 seconds approximately. And I get a countdown clock here. Now, when we get to the end of this notebook, as I said, we're going to do inference. We're going to do inference. And so we're going to define a function to do inference and grab each of our images and show the result. We have this function here which just lists out all of the weights. So we saved weights of the 1000th iteration, the 2000th iteration, the 3000th iteration, the 4000th iteration, and the best weights, which were the best ones that were used across training, as well as the last and final weights. We save the names of our objects on top of the Cocoa names so that our labels look correct. And then we just grab one of our images and we randomly print it out. So here I've randomly grabbed one of my images, printed out the image path, and then run detection using Darknet on that given image path, and then show that prediction. So here we randomly grabbed this image and it got it right. There's a dog. Randomly grabbed an image, got it right. There's the dog. Randomly grabbed an image, got a dog. Randomly grabbed an image, and this box could be better, but it got it right. It's a dog. And here, a person and a dog. Boom. There you have it. YOLO v4 Tiny running on thermal infrared images to detect any object. In this case, the person or the dog that it sees in each of the images. Now, that's kind of it. I mean, I can't wait to see what it is that you are going to build next. Please drop anything in the comments, questions that you want to see, and don't forget to like and subscribe so you can see when we're releasing new content. Thanks so much.